Hi, welcome to the shop. In this series of videos, I'm going to be assembling the bent wood pieces for the frame to go around the Damascus style murrine. This is a long process because each of the layers needs to be glued, give some time for the glue to cure, then machined, then another layer glued. So overall there's 5 machining operations, 7 total layers, and 6 gluing operations. So let's get going. Now that the pieces have been pre-bent, some of them have been bent more severely than others, but I believe they will all be acceptable for this operation. Of course, like everything in this project, this is the first time through, and hopefully I won't have unpleasant surprises. I'm now going to glue together the first 2 pieces. I can't glue them all together because the design that I have in mind requires the first 2 pieces to be glued together. Then I need to put the fixture, the holding fixture, into the mill the second piece to get a nice razor sharp point, then glue on the next piece, mill it to a point, next piece, mill it to a point, and on and on. This makes the process really, really slow. So it doesn't take a whole lot of time each day, but it's going to take a lot of days. Now I'm going to mix up some plastic resin glue. I want the glue joints to be extremely rigid and structural, and I want to minimize springback and creep and anything that I might get if the glue is even the slightest bit flexible. And this is a special resin glue, powdered glue that is mixed with water, and it's specifically designed for veneering work. And in the past, in my other veneer designs, it's worked really well. So I'm going to mix up a little bit of it here. I don't need much. I'm going to start out applying some glue to the mating surfaces. My first layer is going to be the birch, followed by the mystery wood. I think it might be olive wood, I don't know, but probably need to be more careful at the hardwood supplier to remember what it is that I actually bought. So there they are, roughly in place. Get the clamp going here. This doesn't have to be lined up within a fraction. The pieces are generously oversized, and oversized in both dimensions, and I don't have to be exceptionally precise about the alignment. As long as it makes it to the edge, it'll end up being a successful result. So there we go. The first assembly and I may apply another clamp over there just to be sure. The fixture was designed for the final size. When all of the pieces are stacked up, this width will be the same as the final stack up. But for now, I believe we can call the first 2 layers very nicely done. So let me get the camera over here. There we have the first 2 layers. As soon as the glue dries, it's off to the milling machine, and we'll see how the milling operation works. Hopefully it will be successful. Moving over to the Bridgeport now, I've got the part trimmed after gluing in the fixture, and now I'm going to machine its profile because the pattern is not a simple parallel lamination. The idea is that the inner pieces all come to a point. They're fat on the bottom, and then they get smaller and come to a point up at the top. And in order to do that, I do glue, and then followed by, let's make sure that this is going to clear. Glue and mill and glue and mill and glue and mill until it's finally complete. And it looks like I do have a small conflict here. And I don't believe it's going to be a serious conflict, but okay. I've already zeroed the mill. I was doing some other work this morning off camera, and so I already zeroed the mill, and the 0 point is at the back of the vise at the left side. So it knows where 0 is. I use the Heimer indicator to do that. Now I'm going to load up a cutter. Now, this is cutting wood, and I kind of debated with myself, should I do this on the Bridgeport or should I do this on the wood router? The CNC wood router operates at 25,000 RPM, and that's a better rotation speed, surface feet speed, better overall for cutting wood, but I'm a little more confident and comfortable using the Bridgeport 2-axis because the 3-axis wood router, it's once you push the button, it's going to do what it does, and if it decides to go crazy, well, then I just ruined a whole bunch of work. So I'm hoping that the 4,200 RPM with a sharp, nice half-inch milling cutter is going to be sufficient to get a nice surface finish on this thing and not split it out. I am going to be using climb milling specifically for surface finish and to try to avoid split out, because I am somewhat concerned about the wood grain splitting. So let's go over here to the network. I've pre-computed the tool path, and now I'm looking at it on the screen, just kind of the first level of sanity check, and yes, in fact, it looks reasonable. I'm now going to reset the controller because it's always good the way the controller is set up with the Windows computer running Mach 3 connected to a Galil motion board. It's possible when you turn the servos off to move the table around, and then if you simply turn the servos back on, they take off in whatever direction they feel like. So before turning the servos on, I always like to do a reset. So let's turn the servos on. And one of my favorite things about the 2-axis milling is that with the Z-axis up, I can do the next level sanity check and verify that, yes, in fact, it does look reasonable. It does not look insane. And I think that's enough of a check. So now I'm going to stop, rewind, restart, and even though I don't need to because it's pretty apparent where 0 is, I'm going to go ahead and set Z0 to my tooling plate. I don't want to ding up my tooling plate, so I want the final cut to be a few thousandths above 0. So let's return to the starting position. I'm going, even though there's a really good chance that this cutter could just zip through that wood in one pass, I'm still concerned about tear out. I've never done this before, so I'm going to take it slow, take it conservative, and just do it in multiple passes. Exactly as I wanted it. It's barely kissing, just barely taking just a hair off here, and then getting down to pretty close to a 0 size at the end. So, wrap it back for the second pass. All is looking very well. I think 3 passes will be an appropriate number for this. I'm very happy with the result. I'm not getting any split out at the extreme corner where the bend was so radical and the wood fibers are stretched. I'm not getting any tear out or split out, and as the layers build, this radius will get to be a larger diameter and I'll have less problems. If I was going to have a problem, it would have been on this cut. So now I'm going to go almost all the way to 0. I'm going to go I'm going to go 10 thousandths above the tooling plate. So far, this is behaving perfectly well, exactly as planned. And now that as soon as I said that, I believe I have a little split out, and hopefully when I put it in the clamp fixture, it'll all close up and it will not be a showstopper, but this is what I was concerned about. There's a tiny bit of split out. It looks to be clean split out that should very nicely form back together, but definitely something that I need to be aware of as I continue the process. So I still believe that I'll be able to salvage the piece. I don't believe that this is a showstopper, and we will see. Okay, I'm moving over to the gluing area here, and let me make sure that I have this right, because I don't want to get this wrong. Make sure that I have the correct next step. The next step is going to be walnut, and so I'm starting 1, 2, 3, 4. Okay. I've switched to Titebond glue. The glue that I used in the first little video segment, I originally thought that it would be superior glue, but it just didn't work at all. Totally came undone. I didn't show the re-gluing on camera, but it's just re-gluing. Not that horribly exciting. So I switched to the Titebond. I have no idea why the super duper fancy glue didn't work, but I'm reasonably confident in Titebond. I use it for almost everything, and I just kind of got this crazy idea, oh, I want to go to the most extreme glue that I've ever used, the one that I don't use very often, and it surprised me with failure. And okay, so I believe that I will be able to nicely close up that little split. It looks like a very nice clean split, and I think it will close up just fine. I think that I'll be able to continue the project, but like I said in the beginning, this is highly experimental. I've done a lot of bent wood in the past, a lot of laminated wood in the past, but never this particular design on this particular fixture. So that looks really good. So, as the layers stack up, I'm having less and less need to use the auxiliary clamp, but, you know, why not? Why not be a little extra secure? So, I'm going to let it dry overnight. Titebond should dry in a few hours, but I'm going to let it dry overnight just to be sure, and then come back, mill, and then just repeat. There's going to be 7 layers, 5 of which require milling. The outer layer will be the full thickness of wood, and all the inner layers will be milled. And tomorrow morning, I will mill this one. And hopefully when it's done, it's going to end up looking great. But hey, that's what R&D is all about. Well, it's been another overnight curing for the glued up parts. This is the third lamination, and I'm using the Titebond 3 glue after what I thought was the super duper veneering glue. After it failed completely, I'm now using Titebond, and I've always had good results with Titebond. I think it's a really good glue. So glue line looks really good, looks really tight, piece looks really good. I'm gonna cut these protruding pieces off on the bandsaw and then head over to the mill. Moving back to the Bridgeport, I've got, I believe everything is ready to go. Since this is the first work of the day, I need to find 0. I usually leave the machine at 0 when I turn it off, but I'm not really confident that leaving it at 0, who knows, it might get bumped. So it's just so fast. The Heimer works exceptionally well. So, as I said before, having set the 0 with the Heimer, I'm now going to reset the controller, activate the servos, and go to the 0 position just as a kind of a sanity check. Love that power drawbar. Now, as I said in the previous video, I've got the corner ground off the tooling plate to remind me that the 0 point is set at the back of the vise in the left corner, so I can return the tooling plate to the 0 position. I'm using maybe you can see it there, using a 3-flute carbide milling cutter, 3-flute solid carbide milling cutter. This is one from Lakeshore Carbide, and it's sold as an aluminum cutting tool, and I primarily use it for my work in aluminum, but it's new, it's sharp, and seems to work pretty well for cutting wood. And as I said in the previous video, oh, and a little digression here, I'm setting the 0 on the DROs so that I don't drive the cutter into the tooling plate. I want to stop about 10 thousandths above the tooling plate. As I said in the previous video, I've been debating whether or not this is the correct procedure, and thinking that, well, maybe I should be using the wood router with 25,000 RPM and a real router bit, but the Bridgeport 2-axis, it seems a little more comfortable for me, a little bit less chance of making catastrophic mistakes, and it seems to be working well, so I'm not going to complain. 4,200 RPM is not quite 25,000, but you know, it appears to be working reasonably well. So, do my quick sanity check. One of my favorite things about using 2-axis CNC is that I can do this kind of a sanity check. Just have with the Z in a safe position, and just make sure that, no, I didn't make a mistake in file numbering, I didn't make a mistake in toolpath generation, things look fine. Going to be doing it in 3 passes, even though it probably would work to do it in 1 pass. I'm just being a little bit extra careful. So far, everything's looking good. Cut quality looks good. Geometry looks correct. In this assembly, there are 7 layers of lamination and 5 milling operations. This is the 2nd milling operation on the 3rd lamination. So, going to be going down to about 10 thousandths. I'm looking here on the DRO, about 10 thousandths above the surface of the tooling plate. I don't want to ding up the tooling plate, and that extra 10 thousandths of a little bit of glue and a little bit of wood I can easily clean up with a utility knife. And result is looking beautiful. I don't have any tear out. I'm using climb milling specifically to try to get the best surface finish that I can get. And this is looking very, very nice. I believe that all is well. So, gonna go back over to the glue station and put on the next lamination. Okay. So I'm back over at the glue station now, and I'm selecting one of the pieces of the pre-bent material. giving them that little bit of bend, even though I have a substantial amount of spring back, giving them that little bit of pre-bend, steamed pre-bend, seems to help a lot. Even though now the wood is dry and it's not steamed, having that pre-bend at the extreme corner of the radius seems to help the process a lot. I've used this method before on other projects, and it seems that even though the steam bent part springs back a lot, having been bent improves its ability to bend in the clamping fixture after the wood has dried, and ends up producing excellent results. I've been able to get very tight bends in previous projects where if I just tried bending it dry from the beginning, probably would have ended up in catastrophic failure. So let's get the bending jig is working exceptionally well. I'm very happy with the results that the bending jig is producing. And of course you might be wondering, did I go through all that work just to make one part? And the answer is, well, maybe yes, maybe no. I'll probably end up making 3 of these, but my overall philosophy, I don't mind making a fixture for one part. If that's the only way to get the one part done correctly, I'll make a fixture for one part. But if this turns out really well, who knows? I may make a lot more. But of this set of murrine, this Damascus style murrine, I have 3 nice polished slices that would go nicely in these guys. So probably going to make 3. Probably going to let that one cure overnight, even though Titebond, I believe that it's actually ready to go. It's good to go in a few hours. I'm just going to be extra careful, let it cure overnight, and come back again tomorrow. Well, another day, another layer. Let's release the clamp and look at this. This is now the 4th layer that has been completed. See if the camera can focus on it. Everything is looking really, really nice. The glue line looks really tight, and everything, there's no gaps, there's no split out on the edge of the wood, and everything looks really well. The bending fixture has been working exceptionally well, and so far looking really good. So off to the bandsaw, and then back to the mill, and do the next trim operation. Between every layer is a trim, and to review, there are 7 layers total, and 5 of them require trimming on the mill. So back over to the Bridgeport, and this is the first use of the day, so back to the Heimer. Let me make sure that the air is turned on. As I've said before, the Heimer is an amazingly quick method of setting 0. And I realized that if I was doing the most precision work, that the Heimer does have, it's good, but it's not as good that a traditional kind of wiggly kind of center finder device, one of these little guys, that actually it finds the center of the rotation axis of the spindle independent of the run out of the collet or the inaccuracy of the sensor. And so if I was trying to get the highest possible precision, I'd probably end up using the traditional center finder. But for this operation, 1,000th here, 1,000th there, the Heimer is so fast, and it really does a good job for me. I don't really have any problem using the Heimer, and so I'm very happy with it. But I also understand, I believe, who was it? I think it was Tom Lipton, who did a very informative YouTube video on what actually are the various different edge finders measuring, and which ones are independent of the run out in the collet, and which ones have a variety of other inaccuracies that need to be considered. So, once again, after setting 0, I will do a quick sanity check using the manual input on Mach 3. Just tell it to go to 0, verify that everything is right, that I didn't make some kind of silly mistake. Double checking, cross-checking, verifying, always a good idea. It's so easy to make a mistake. And yes, I do make mistakes. I make lots of them, but I try my best to always double check and cross check and avoid mistakes whenever I can. So let's go over here and I'm going to set the 0 so that let's get this. I'm going to set the 0 with the tip of my tool touching the tooling plate, set the 0 on the DRO, so that I can, when I make my final pass, have the cutter about 10 thousandths above the surface of the tooling plate so that I don't ding up the surface of the tooling plate. 10 thousandths is fine for woodwork. I clean up the edge either with a chisel or with a utility knife, and I end up with a nice smooth surface for the next lamination. So I just remembered now that I don't have a tool path for this cut yet, so it's off to the office, and I'll be back in a matter of minutes. Well, that was quick. Very nice thing about the way the shop is set up, the office is right next door, and all of the CNC machines are on my network, so I can just walk over to the office, create a toolpath, modify a toolpath, come over to the computer, load it up, come over to the CNC control computer, load it up, and I'm back in business. So once again, standard operating procedure, sanity check. After having spent this many days on this project, I certainly don't want to booger it up in the last steps by loading a bogus toolpath. And so, once again, this is the main reason that I'm doing this project, even though it is cutting wood, and the proper wood cutting tool is the CNC wood router operating at 25,000 RPM. The wood router is a 3-axis machine, and it's not quite as convenient to do a sanity check. Yes, I can do it, but it's not quite as convenient. And so on the Bridgeport, I have that extra little bit of confidence that, yeah, things are going right, I'm not going to screw it up. And so, and the 4,200 RPM speed seems to be adequate. It's producing a very nice surface finish, and I'm not getting any tear out. And in case anybody cares, 10 inches per minute feed rate. So, doing it in 3 passes. If everything was perfect, the cutter would only barely touch the outside edge of the radius. What I'm observing here is that the cutter stopped cutting right about at that point and probably missed the point here by a couple of thousandths. This will not be a showstopper. It will not make the part useless, but the next one I make, I'm going to make my slices just the tiniest bit thicker so that I get that slightly more perfect geometry. It's looking like the first one is going to be a success, and I'm going to have a nice looking result. But just in general, in my projects, it usually ends up that the third one is the best one. The first one, in most cases, I can make the first one work. The second one gets a little better, and by the third one, that's about they're dialed in about as well as they're going to get. And as I make more after the third, they really don't get any better. So now, going for looking at the DRO, operating the quill manually, going for 10 thousandths above the surface of the tooling plate. And that completes the operation. Everything looks very nice. The result is coming out exceptionally well. There's, as usual with all of my designs, I can see some very, very slight differences from the way the design was intended, but this one is so far looks like it's going to be perfectly successful, and I think it's going to come out really good. And of course, the next one, if I make two more, the next one will be better, and the next one will be better. So back to the glue, back to the clamp, back to the glue again. Gonna just hit it with a chisel here just the littlest bit to clean up. I got a little bit of glue ooze. I've got just the littlest bit here. So there it is, cleaned up with the chisel, and I'm going to be using walnut here for the next layer. This is the 5th layer. And once again, using tight bond glue, for some unexplained reason, the powdered plastic resin veneering glue that I believed would be a better choice completely failed. I mean, completely failed. I mean, the part just popped off as if there was no glue at all. So, very surprised by that. I've used that plastic resin glue before on other projects for veneering, and worked great. But I've also used a lot of Tight Bond, and this is the Tight Bond 3, and works really, really well. So, get that clamping fixture in place, and as I keep saying over and over again, the clamping fixture is a great success. Everything is working exactly as expected. I have lots of experience making bent wood projects. When I had my cabinet shop in the 70s, my specialty was bent wood. And I used to make fairly elaborate and complex bent wood, mostly modern furniture, office furniture, things for radio stations, and I used to make very complex bent structures that other woodworkers would look at and say, "How do you do that?" So there we have, clamped up, looking really good, and gonna let it dry overnight. See you tomorrow. Boy, this is a slow process. Oh, another day, another layer, back again. And things are looking really good. The clamping fixture is working exceptionally well. The pieces are looking really good. See if, yeah, see if you can see how they're getting thick on this end and thin down here, which is all part of the design. So it's off to the bandsaw, chop off the nubs, and then off to the Bridgeport, and we'll mill this one. This will be milling operation 4 on layer 5 out of 7 layers. And so we're getting close to the end. And back at the Bridgeport again, even though I parked the machine at 0, and I could probably just go ahead and use it because it's probably close enough, but still, it's so fast just to load up the Heimer. And okay, so the stored X position where it thought it was 4.3 thousandths away from where the Heimer says it is right now. So, and then this one is 3.5 thousandths. So it probably was worth resetting. So I reset, start the servos, move to the 0 position, verify that it looks reasonable, wrap it over, remove the Heimer, get my air hose, parallels, tooling plate. I use tooling plates for just about everything I do. Find them very, very useful. And not only do I use them, but when I'm designing my parts, I typically design parts based on, well, first of all, based on the machines that I have, and second of all, based on the idea that I'm going to have tooling plates. So, once again, touch the surface, the Z surface, over to the DRO, zero out the Z, start the program, and do my sanity check, verifying that yes, the image on the screen looks reasonable, and the end of the cutter looks reasonable. It's reasonable, it isn't perfect. I think I have a small discrepancy. I think that my glued up pieces ended up being a few thousandths too thin, and as a result, as they stack up, the point here gets shallower and shallower. I don't believe it'll be a showstopper. I think the part will still look really good, but if I do another one, I'll probably make these sections just a few thousandths thicker. And of course, that's doing woodworking to metalworking tolerances. Yeah, it really isn't that bad. It's only missing by just a tiny fraction, and I think it still looks nice and uniform and smooth. So I think the overall aesthetic effect of it is going to still be excellent. Continuing to be very conservative, even though I'm pretty confident that I could do this all in one pass. It doesn't take that long to do it in 3, and after all this work, I'd hate to have a problem. So, yeah, I think it doesn't look like there's much of a discontinuity. It looks like the amount that this is too thin at the end is just a couple of thousandths. So I don't believe I have a problem. And that looked funny, but I don't believe it's a problem. So now, over to paying attention to the DRO, dialing in 11 thousandths, clearance off the top of the tooling plate. And all is looking well. And there we go. This little booger right here is just, it's not in the pattern, it's just a little booger, so I don't believe that's going to affect the design. Probably just a little glue booger. So let's send the machine back to 0, turn off the servos, and back over to the glue station. I'm going to take a chisel here and just kind of clean up that little remaining 10 thousandths, clean up whatever glue ooze happens to be on the tooling plate, and clean up that little booger on the end. And no, it didn't affect the pattern. The pattern is still totally fine. All is well. So the tight bond is working really well. I've had really good luck with tight bond. It's good stuff. And once again, I have absolutely no idea why my super duper veneering glue did not work correctly. So I'm going to be selecting a piece, selecting some of these. Some woods bend better than others, and this mystery wood seems to have more problem with cracking at the outside edge. This outside edge is just fine, And I believe that the amount of pre-bend that I have here is going to be sufficient, because in the outer layers, the radius is going to be so much larger. And I believe that I will get a nice clean bend here. The fixture is holding up extremely well. Yes. And I probably will cut a little off the sides here. I spoke a little bit incorrectly previously when I said that the size would become more correct as the design approached completion. It actually appears to be getting less correct as the design approaches completion, resulting in a larger need for the auxiliary clamp. But hey, it's working. Not going to complain. So once again, going to give it an overnight cure. Come back tomorrow, make the last CNC profile cut and the last gluing operation, and yeah, see if we can get this pig to oink. So the end is finally near. This is going to be the 5th and last milling operation, followed by one more gluing operation, and then the assembly will be finished. So make sure that the camera is actually seeing that. And now that I see how the fixture is working. The fixture is working really well, but this width was actually a little too much. I think I'm gonna bring it down for the last gluing operation, and fortunately making things smaller is easier than making them bigger. So off to the bandsaw, cut the ends off, and then it's off to the Bridgeport. So back again for the last milling operation. This is milling operation number 5 on the 7-layer wood assembly, lamination assembly here. And starting off as I always do, finding 0 with the Heimer. This is so fast that it's just not a problem at all. At one time I considered the possibility of retrofitting the Bridgeport with absolute scales so I wouldn't need to worry about zeroing, but the Heimer is so fast that, hey, who's going to argue with that? So, this has been a long process, and hopefully the result will be worth it. Of course, I hope that I don't get a crazy idea to, hey, maybe I should do a 50-layer project. I'm not sure that I'd be happy with 50 days of gluing and milling. I think 7 might be a good number. So, go over here once again. The toolpath is all on the network. Toolpath was created in Bobcad CAM software. And like I always do, going to do a 2-axis sanity check with the Z in a safe position, just to verify that all is well. Yes, that does look sane. Now, I'm going to jog over here and set the Z0. And start the operation. Similar to the previous pieces, my tolerance stack up here has resulted in the point being a slight bit too short. I don't believe this is going to affect the design. I think the design will still come out nice. The transition here is smooth. It's not discontinuous. And the design element that I really wanted to see was the taper to the point on the end, and I believe that that will still look the way I want. The actual thickness at this point is probably not going to be noticeable, and if I didn't tell anybody that it was there, nobody would even know it was there. So next one I do, I'm going to make the strips just a little bit thicker. I tried making the strips to the numbers, to the precise numbers, and for one reason or another, when it all stacked up, possibly they got a little thinner in bending, possibly, I don't know, possibly I made a mistake somewhere, but I don't believe it's going to be a problem, but just in general, in all of my projects, I'm always trying to improve. No matter how good they get, I'm always trying to figure out how to make the next one a little bit better. So, going over here on the DRO to 10,000ths, above the top of the surface plate. And it looks really, really good. I am very confident that this design is going to come out as intended, and it's going to look really good, and it's going to be a nice complement to the glass murrine piece that also came out really good. So that completes the the final milling operation. So one more glue, one more layer of glue and wood, and then we get to see how it all looks. So there we have it. Get up close to the little guy here, and off to the gluing station. I shortened this part of the clamping fixture off camera. It wasn't that exciting of an operation. Actually, none of this is very exciting. It's all kind of repetitive. Another layer, more glue, more milling, using the chisel here to just barely clean up that little bit that was left because the cutter was only 10/1000ths above the surface. Everything is looking really, really nice. I'm gonna put on the final layer of wood, and I think the result is going to come out very, very nice, but wow, this is a slow process. And I'm going to select, this looks like a reasonable pre-bent piece. Even though the pre-bent piece is substantially larger radius than the target, the pre-bending does help. If I tried putting a flat piece in, just flat and cold, it might work. I might actually have success, but in the past I've found that things tend to work a little better if I give it just a little bit of pre-bend with the steam. And in the past, I've used both steam and hot water, and kind of had better luck with hot water than steam, but for this one I did use steam. So here we go, and a little off center here. More than a little off center. And that, I do notice a bit of a problem. After saying all that about how the bend was coming out so nice, it appears that I have a little split. So while I have the chance to fix it nicely, I'm gonna add a little glue. The bending process, it's somewhat predictable, but every piece of wood is a little different. And I've had mostly success doing my bent wood pieces, but sometimes they surprise me. Make sure that I have a sufficient amount of glue here. I believe that is going to be just fine. The bending fixture has performed exceptionally well. I do have, because of the geometry of the piece, I do need to put on the clamp to get that final little bit of angle. So there we have it. This is the final. Let me make sure that I have this in the frame. This is the final glue up. And next step, after the glue cures, take it out, sand it down. The rough cut pieces are a 1/2 inch here, and the final piece, when the thing is finished, is going to be a little over 1/4. And like everything in this project, I make it just a little bit bigger, so I have a lot of room for adjustment, a lot of room for fiddling and diddling and making mistakes and recovering from mistakes. And yeah, it's been a long process, but I am anticipating great success here. I'm really optimistic and I'm looking forward to it. So we'll see tomorrow. So finally, it's time to take it out of the fixture and let me get the take the top clamp off here. Now, I don't expect the glue to stick super aggressively to the aluminum, but who knows, it may be a bit of a trick to get this thing all disassembled. There we go there. And maybe if I do another one, I might wax the aluminum. But hey, there it is. And we have You can see over here, no spring back at all. The design is perfectly sized. And yeah, I probably, the fixture is completely undamaged, a little scratched up, so I'll probably wax it the next time I use it. But hey, glue joints all look very solid. I'm going to move over to the sander here. And I'm going to cut this off on the bandsaw first. I'm going to move over to the sander now and see if I can clean this guy up a little bit. So there, very roughly sanded, looking very nice. I'm going to continue the sanding by hand. It looks like the small amount of trouble that I had on the outside edge has been handled nicely. I'm going to move over to the oscillating spindle sander. And I can get some of the staining off the inside. During the steaming and initial bending process, the light wood picked up some of the color from the more highly colored woods. So That's coming out nice. That's coming out very nice. Okay, so now the inside is nicely sanded. Let me move over here to the horizontal sander. And that is looking very nice. I think it's time to stop the machine sanding and get going on some hand sanding now, because the piece is roughed into shape, and now is the time to get a little more gentle and precise with the sanding and shaping. I'm using a piece of 80 grit garnet paper here on my welding table, which is reasonably flat, and if I really cared about effectively abrasive lapping a fine machine part, I'd probably use my surface plate, but this is woodworking, so it's not necessary to get micro-inch lapped flatness here. I'm shooting for a final thickness a little over a quarter. I'm still thicker than I need to be, and I'm very happy with the results so far. I'm gonna constantly examining, just eyeball inspection here. And I think that point needs to come down a little bit. And that's looking pretty good. This is a somewhat challenging shape to sand. yeah, the outside is looking really, really good. The little bit of split out that I had has been completely solved by gluing, and I see no evidence. The grain looks proper. Everything looks really nice. As the shape gets closer to being finalized, I'm getting more gentle and more careful. Pushing hard going forward, and then coming back with almost no force to avoid buckling the sandpaper. I'm holding the end of the sandpaper with one hand and pushing the workpiece with the other, and frequently inspecting and I could do this on the power sander, but those power sanders, there's good news and bad news. The good news is they remove material really quickly. The bad news is they remove material really quickly. And I love them for the roughest of roughing operations, but for the last finish operation, there's nothing like hand sanding. Well, got a little bit of I think my sandpaper is kind of petering out. Yeah, sandpaper is cheap. I'm not gonna waste a bunch of time with worn out sandpaper just to save a few pennies. Getting very, very close to the size I want. Getting very, very close to uniform thickness. That is yeah. I'm going to switch to 120. And actually, before I switch, gotta be careful here. I want the edges to look mostly sharp. I don't want them dead sharp, but I also don't want a big fat radius. Somewhat challenging little piece. To sand. Yeah. Especially the inside here. But it's coming out nice. A little bit on the inside. Okay, now on to the 120 grit. Make sure that I have a smooth surface here on the welding table. And yes, the design looks exactly as I expected it would look when I designed it, so always nice when that happens. Always nice to be able to visualize a project. And especially nice when it comes out as imagined. And that, give a little impression of how it's going to look once it's finished. So after the finish goes on, I'm going to be, well, and the finish that I'm going to be using is what's called conversion varnish, catalyzed conversion varnish, which does a really, really nice job. So here's a little preview of how the murrine piece will be mounted into the wood part, and then the whole thing will go on a metal base, and hopefully we'll have great success when the thing is finished. So that concludes today's, that concludes this week videos, and thank you for watching.